Hello! Hello, 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 hello! Welcome to the new year. How are we all doing? How's things? How's life? How's the universe? How's your week been? How's your year been? It's been a whole year since I've last seen you guys. I have in fact showered this year though. Hello John, hello Jim, and hello Weenie. Hold a sec, how are you? Yeah, same. I'm not well. Happy New Year. Doing well. Honestly, no, but let's pretend. So I have a stomach ulcer. I found that out 2 Saturdays ago. When I had a camera down my throat. Wasn't fun. And it burns. Unfortunately, things never change. I was ill last year. I will be ill this year. Yeah, I've got to have another stomach ulcer. No, I've got to have another gastroscopy in, I guess, 7 weeks, 6 weeks, 7 weeks. It's not been booked yet, so God knows. So yeah. Hello, Jim. How you doing? How's things? Good to have you. Turning 40 this year, but got a head start with a backache and shit. Nice. Fun though, staying home last night. Messed up my belly with chocolate liqueur and Prosecco. Nice. I've got a head start on the year. I started the year suffering. Start the year as you intend to continue. So yeah, I did good too. Hello Chris. How you doing, man? How's things? Happy New Year. Oh dear. I ate a lot of sugar and stuff, that helped. Nice. Good. With the messing yourself up. I figured, yeah. A lot of interesting things go, a little cauldron of your stomach there. Oh. Ha ha ha. So now I'm really dizzy. I started the year with a cracking hangover followed by pancakes. Nice. But you, mate, what are you up to? Mostly suffering. Mostly that. Because I traveled for Christmas. I cracked out the Steam Deck for the first time in probably 6 months, and I had a wonderful time playing Pokemon Diamond, only to accidentally quit the game, losing a full 24 hours of playtime, which really hurt my soul, and I haven't been able to get back to it. I've been almost daily driving a second machine for Linux. I installed Bazite. It's actually the video that I filmed today. Also, if anyone has experience with Linux, and specifically laptops, please help me. So I'm using an Asus ZenBook Duo, which has a Realtek ALC294 audio codec. The speakers and headphone jack don't work. What do? HDA jack retask doesn't exist anymore. Creating an alsa-base.conf file in etc-modprobe.d Helps a little bit. The microphone, the inbuilt microphone starts working, but the speakers still don't. I've tried a few different options for that as well. Like there's Asus ZenBook UX 58A. Someone suggested a Lenovo one, like ALC294-Lenovo-mic or whatever. So yeah, suggestions? Uh, oh, tech. Ordered a 5070 on the advice of the missus. She's a keeper. Looking at the news coming out, it seems like a bad idea on my part to wait for the 5070 Super. Yeah, I mean, with the RAM price, or the RAM apocalypse, oh, I, in fact, this is what life has been like for the last 2 weeks, 3 weeks. Because of the RAM apocalypse, a friend was asking about Battlefield 6 and buying a GPU to use. I suggested buy it now because prices will skyrocket as the price of the new cards climbs because the RAM prices climb, and scalping and stock and availability. The price of the old cards will go up commensurate with the new cards. So if you're going to buy a used GPU, especially a high VRAM one, I would personally recommend buying Student TM. Supers may not happen or be delayed. Yes, I agree. She says, yes, I am. I'm glad she knows it. Wondering, with components like RAM, GPUs, and SSDs all going to crazy prices, do you think other components like PSUs and cases could drop in order to encourage purchases since they would normally sell along with those components? So honestly, I don't think so. I think that would be a very big brain move, and maybe an SI or whatever, like someone like Corsair or Asus or Gigabyte, who are people who make basically everything in a PC except the GPU and the CPU. Although, people like Asus and Gigabyte do make the GPU, although, the actual core is from AMD or whatever. I think that sort of big brain move would likely have to happen from one of the big players who can subsidize sales in one department to boost sales in another so that they come out even. Just someone like, I don't know, Height, right? Who like just make cases, or maybe they make some coolers and power supplies. Ow. Um, Someone like Height who just makes, a couple of things like cases, maybe power supplies, maybe coolers. They would struggle to subsidize their own products with any other products, with any other markets that they're in or they're not in. They already operate in razor thin margins. Obviously shipping to the US has gotten way more expensive, so they're even tighter margins, if any, there. So they're already going, well, we're only making 50p from selling this entire, £100 PC case, and now we're selling less of them. They can't then say, okay, well, let's drop the price so that we're now making a 50 quid loss just so that people will start building PCs again. That just doesn't really work for them. Like I said, someone, I guess, yeah, someone like Asus who were going to get into RAM but aren't prices and who are still making DDR4 boards, which is nice. Um, they could potentially pull that off. They could, obviously keep GPU prices the same, but maybe drop motherboards a little bit, drop their own cases, their own power supplies, their own coolers, and especially with especially CPU coolers, they could definitely, take a tenner off there, take 20 quid off there, whatever, to essentially put towards a GPU to incentivize people to buy the whole thing. Although even then, I suspect that they would want to do it where, if you buy an Asus case and cooler and power supply and GPU and motherboard, only then will you get some amount of discount. I would love that, and it's a great big brain move if they could all sort of come together and do it, but I doubt that would be the case, unfortunately. Got 2TB NVMe and B550 because there is no way for the prices to come down. Oh yeah, I got pills in my pocket. Before spring 2027, even if the bubble pops tomorrow. Just waiting on the RMA for the rusty Lian Li Dan A3 I received. I mean, you're right on the RAM apocalypse front, and that's kind of wild about your case. I highly suspect that the RAM apocalypse will be difficult for us to deal with, and the NAND apocalypse that's also coming, which is it's so frustrating. It's infuriating, really, because the RAM apocalypse comes from obviously the demand being higher for all of these new data centers where people like OpenAI and Oracle and Microsoft are building, and Google and Facebook and whatnot are building all of these data centers, and then they plan on flooding those data centers with new systems purely for AI. But the infuriating thing, and then the other side of it, is the supply. There are only 3 primary NAND manufacturers. Obviously, one of them is just pulled out of the consumer market, which is fucking insane. And Samsung won't even sell Samsung its own RAM. And then SK Hynix does SK Hynix things. But they, even if it wasn't a triopoly, they still only have a limited production capacity, and while they are quite certain that the demand will stay strong for a reasonable period of time, they're still not willing to invest, or even able to invest in more, basically just more machines to make the chips. So yeah, wild. And it's all for speculative hype. Infuriating, as I said. Hello, B-Rise. How you doing, man? How's things? Happy arbitrary period defined by Pope Gregory's calendar system. Or, as we say, Happy New Year. I reckon pre-builds will start coming with dirt cheap PSUs and cases. I mean, they kind of, a lot already do. If my 6900 XT dies, I will revert to an HD 7970. Fair enough. Every time I've had things not work on a Linux PC/laptop, the standard update page on Mint has got the drivers. Well, the thing with especially audio drivers is that you have ALSA and Pipewire, at least on Fedora, which is what Bazzite is. And that's basically a one-size-fits-all driver that you can't touch, as far as I understand it. That in theory should work with this codec. It's just whatever settings and configurations is a problem, apparently. The machines to make the wafers are very, very expensive, not to mention the people to run it and the years to build one wafer machine. Yes, with the Asterosk, it depends what type of wafer machine it is. ASML makes everything from DUV or deep ultraviolet to EUV extreme ultraviolet to high NA EUV machines or high something aperture. Numeric aperture? I can't remember. High aperture, extreme ultraviolet. DUV machines are good for well, I mean, DUV can be good for down to 14 nanometer, as Intel will happily tell you. EUV is generally anything less than 14 nanometer, and high NA EUV is generally, although not specifically, what the 1-2 nanometer process nodes are using. Oh, and actually, because I've made several videos about this, so I know, a decent amount. The fun thing about EUV machines, extreme ultraviolet, is that basically what changes for the most part anyway is the wavelength of the light. So ultraviolet light can be in the a couple hundred nanometer range. So you can have 400 or 200 nanometer light, give or take. I think it's like 408 or something, for the early DUV machines. But if you want to make really, really small features on a die, well, you need really, really small wavelengths of light, because you can't wavelength, like, you can't affect something that's smaller than the wavelength. So I'm not well, apologies. So the way that they produce the really low or short wavelength light, specifically, it's not 14 nanometer, is it? 12 nanometer light, or is it 14 nanometer light? I'm going insane and I hurt. So the very small wavelength of light is they fire 4 CO2 lasers simultaneously at molten droplets of tin, and as the tin explodes and vaporizes, it happens to emit extreme ultraviolet light. And they have a big parabolic mirror that captures that extreme ultraviolet light and bounces it around the machine until it ends up getting shone on your like through a mask to the chip. And the high NA machines can do those exposures. Can do those exposures very, very quickly. I don't know what nanometer say DDR5 NAND uses, but it is likely IDV or EV. So yes, very expensive machine still. My body is just exploding in all directions. I'm a droplet of tin being shot by CO2 lasers. Sounds like aliens are involved in that EUV process. I mean, I do have to wonder who was exploding droplets of tin with a CO2 laser and measuring the light output. Who was doing that? Who worked that one out? Because that's very funny, I think. Oh, actually, I have a fun fact about TSMC that I wrote in a video. Um, mm, mm, mm. So TSMC uses 101 million cubic meters of water a year. Which, just because it's me, that is 13,466 times the amount of water in Loch Ness. You could drain Loch Ness 13,466 times per year, or you would have to, just to fulfill the water needs of TSMC. And AI in general is expected to use 6.6 billion meters cubed of water by 2027. Um, it's crazy how they're made, way above my understanding. I actually have a video on how the chips are made. It's really cool. Looking at the upcoming memory apocalypse, I decided to get a GPU upgrade before the prices go totally mad. Got a 9070 XT as I'm running Linux on the desktop. Nice! That's decent. Good odds of finding Nessie then. Aye, indeed. I heard a curious thing about consumer RAM and flash memory was that both are generally in stock, so there is supply. Stores can only overcharge because of the uncertainty in the market. What do you think of that? So there's a difference between stock and supply. Now, to be clear, I do not know anything, any specifics. I've not spoken to any retailers or e-tailers. This is a hypothetical answer, right? But hypothetically, you could have RAM and SSD still in stock and basically no new ones coming in. You could also have plenty in stock right now, but only 2 or 3, sticks of or packs of RAM coming in every day, week, month, when you would normally have 100 or 1,000, right? The uncertainty in the market is it's unlikely to be the case from an individual retailer perspective, like a store perspective. So I work with Overclockers UK and well, at least have done. I haven't spoken to them in a little while, but I know them reasonably well, so I'll use them as an example. Overclockers UK will buy RAM from, actually, depending on who they're buying it from, it might be from an intermediary or it might be from the manufacturers themselves, but it's probably from distributors. Because what tends to happen in the channel, not the channel as in like the English channel as in like sales channel. Someone, let's say, use Crucial as a rest in peace example. Crucial will make some RAM. They will then go to Symantec or whatever they're called. There's a bunch of like tier 1 distributors. So Crucial will sell, let's say they make 10,000 sticks of RAM. Made. Crucial have made 10,000 sticks of RAM. They will go to their tier 1 partner, or maybe a couple, and basically sell that all at one go, all at one price, and it'll be bulk order price. So if a stick of RAM, let's say, is normally $100, they might sell it to Symantec or whoever for 70. Symantec will then turn around to someone like Overclockers and say, hey, how much RAM do you want? an overclocker say, oh, only 1,000 sticks this year. Actually, let's make it simple. 100 sticks, 100 packs. So Symantec goes, cool. That'll be 85. So they get to make their markup. Overclockers then takes it and then sells them at 100. So they get to make their markup. Now, especially with larger stores, so something like Newegg, even overclockers, because they're part of Case King, maybe even someone like Mind Factory, all of those people will be buying either directly from the manufacturer or from like a tier 1 distributor. And none of those individual people generally has the uncertainty, because they generally have like service contracts and agreements for that sort of stuff. But also, someone like overclockers can't or won't change the price of a product that they've already bought. So if they've bought that RAM for 75 or 80, whatever I said it was, 85, they won't or shouldn't change the price of that RAM to increase their margin on the RAM they've already bought. It's only the new stuff that's coming in at a higher price that they will then want to mark up. Amazon, different beast. Amazon is much more likely to be pulling that kind of pricing bollocks. So yes, and like eBay, definitely. But from larger stores, I personally think that it's somewhat unlikely that their own like uncertainty in the market will cause them to raise prices now. And instantaneously as well. And yeah, the idea that because there may be some supply, or even just that there is currently stock, doesn't necessarily mean there is adequate supply to match the demand. And obviously, supply demand changes prices. So yeah, hopefully that helps. Crucial makes some RAM, then dumps it into the English channel to lower supply and raise prices. That's a good one. I mean, that's basically what Micron did with the brand. Create something, make, last it, like, spend a lot of time and effort making a trustworthy brand, and then dumped it in the English channel to what, raise stock prices, I guess. I hate this. But yeah, there you go. Right. Brain's back on track. So as I was saying earlier, if you're planning on buying especially used GPUs, I would personally consider soon, possibly same with SSDs, and RAM feels like a bit of a lost cause right now. I mean, if you can use DDR4, that might be a better choice. But hello, Simon. Happy New Year. How you doing? How's things? I'm surprised this tech is affordable as it is, being all the tech that's in it. $100, pounds, whatever for a CPU. That's wild. Yes and no. As someone who has, let's say, studied the process, the CPU, like, so, an AMD CPU today, for a $100 one, that's going to be, you know, a single chiplet die and an IO die, if you take the heat spreader off. So there's two main chips there, and the chips themselves are the things that cost the most money. So those little chiplets, which are absolutely tiny, for the $100 one, the probably maybe 6-core, maybe even quad core, no, probably 6-core at $100. Two of those cores on that little chiplet don't work, right? They've been lasered off because they were a partial failure. Now the wafers that they make are 12 inch or 300mm wafers, and if you do a wafer yield calculator for the die size, you get over 100 wafers, 100 chips. Actually, that might be several hundred actually, out of a single wafer. Those single wafers, the highest price that I've ever seen listed for one was $65,000 per wafer, for someone like TSMC to make it, and it's probably lower than that if I had to guess for someone like AMD who's buying thousands of wafers at a time. But let's say it's 50 grand per wafer. Well, if you're making, I can't remember how many it is. I think it's like 300 chips. So if there's 300 chips per wafer, you're looking at, I can't do maths in my head. It's almost a 1-to-1. No, brain's gone. Is it 100? Hold on. I wish I had a brain. Yeah, so it's $166 per chip. So, I mean, on that maths, if I've done the maths wrong, which I think I have, for higher end chips, it makes more sense. Those lower end ones are the ones that would have been rejected if they'd only made the higher end ones, so they get to sort of split the difference. The core designs are evolved over time, so again, kind of makes sense. But yeah, now I need to look it up. That one. Something a normal person would never figure out. That's true, I am autistic. Happy New Year, Serene Sunset. Oh. I guess it's not that one. There we go. So the low end ones are scrap that they use to get some of their money back. Basically, yeah. So the reason that there is segmentation between, let's go with the single die ones, an 8-core versus maybe a quad core, is that the 8-core dies are full complete dies, no errors, no nothing. The 6 cores, they had at least 2 cores with failures, and the quad cores, they had potentially up to 4 cores with failures. And that way, instead of just throwing them in the bin, they get to just sell them as a lower end part for less money. So I think, give or take, a die is about that. So yeah, I was wrong about the numbers. Let's say hypothetically that AMD's chiplets are 8mm by 9mm, which I think is about right. That puts them at 72mm square, which I think is about what the Zen 4 ones were. That means that they make 841 full dies, 96 partials are around the edge. On average, with just the default yield, which I'm pretty sure the defect rate is a bit different for the various models, but would give you 58 defective dies and 783 good dies, which means that the chiplet themselves would cost $25 per chip, potentially not including the good, the bad, or partial dies, or the defect dies. So yeah, that's kind of like, you got $25 for the die itself, whereas sorry, my stomach's hurting and it's quite difficult to focus when you're in pain. You then also have the IO die, but that's made on an older process node. It is slightly bigger, but it's, again, older process node, which makes it cheaper. So, again, you're potentially talking, let's say, another tenner for those per chip. So you're talking about $35 per chip in silicon. The packaging, as in like the heat spreader and the PCB that it sticks onto, all the caps that go on the back, you could, let's say it's another tenner. It's probably pretty high, but let's say it's another tenner. So you're talking about $50 for the hardware cost. Add another 10 for like retail packaging, and like testing, even though it's automated testing. So yeah, you're talking about like $60 for a single die chip. So what do the E cores on an Intel CPU do if it already has cores, like a 6-core 12-thread CPU? Intel, since Alder Lake 12th gen, they've had a hybrid core architecture. So you have your P cores, your performance cores, and your E cores, your efficiency cores. Intel, until very recently, has done everything with a single die, which is part of the problem. So Intel's dies are much, much larger than AMD's. So they might only get 100 or 50, probably more like 100, dies out of one wafer. And if there's an error in those, it could be an uncorrectable error. Ow. And there's more edge loss as well. So Intel's always had a cost disadvantage compared to AMD since Zen 2. Zen 3? Zen 2. I can't remember. Yeah, monolithic versus chiplet. It's only recently that they've gone to partial chiplet. They call it tiled. But anyway, Intel's hybrid cores, the P cores are the full fat cores, which used to have hyperthreading but now don't. Whereas the E cores are a little cluster of 4 or 8, depending on how many clusters. Or isn't there one with 2 sets? Like there's 16 E cores or something. Anyway, the E cores do still function as cores. In fact, there are Intel chips that only have E cores. Life is difficult. So they do act as cores. They just don't have as much power, and they don't have as many features built into the cores. So certain tasks require the P cores because the P cores are the only ones that have, say, AVX instruction support, for example. So yeah, the E cores still do stuff. The general thought process is the efficiency cores are really good at just keeping stuff ticking over. So all of your operating system stuff that doesn't take much horsepower, but just needs to, a clock tick, a window update, a little, window animation, a little, like every time, you type something on the screen and this pops up, my CPU had to render that. My CPU had to talk to the network card to get this information, and then it had to start drawing it. All of those little cores can be doing that in the background, while the big heavy performance cores that take a lot of power just to turn on, let alone do stuff, can be physically turned off. Then when you launch something like a game, those P cores turn back on and you get full performance out of them, and the E cores still get to hide in the back doing all the little operating system things. That's the theory anyway. Practice, it's a bit difficult. Although I should add that if you have a smartphone, you have a hybrid chip. The chip that is in your smartphone has big cores and little cores. ARM kind of did it first. It's called ARM Big Little. And yeah, your phone has efficiency cores and P cores, big and little cores, to do that sort of thing. So, you have really efficient ones that just, when your screen pops up with whatever, or, talking to the cellular modem, talking to GPS, whatever, all that sort of stuff can be handled really efficiently. And then when you boot up a game or start, doing lots of stuff, the performance cores kick in. You don't see them on AMD's CPUs, that's correct, because AMD have opted to just make their regular cores more efficient. So instead of having two different types of cores and the complication of your operating system having to work out which core to send stuff to, added latency of sending it to the wrong core and then having to move it, especially for performance tasks. If you just have really efficient, good cores, you don't really need that so much. Didn't they ditch hyperthreading because of the thermal problems they were running into at 5+ gigahertz frequencies? If everything was good, hyperthreading would still be a thing for Intel, I reckon. So Intel said it was for efficiency and for physical space constraints. For those who don't know, hyperthreading was basically a way of making a core do more stuff. So a single core can actually do multiple instructions at once. It gets complicated. Don't ask. But what tends to happen is you have the fetch, execute, fetch, decode, execute cycle. I think there's another one on there, but my brain's dying. So you have to fetch the data, work out what it says, and then you can, add, subtract, multiply, divide, whatever you do. It's actually only add and subtract in low level, but so you've got to do all of those things, and basically what would happen is your one core would go and fetch something, and then it would have to wait for that thing to return, and then it would have to wait to decode it before it could then do something. So they worked out, well, what if we just have two queues? Two different threads that you can assign to the same core, and then while the first thread is busy waiting for something, the second thread can execute something. Intel says, well, that is good efficiency, but it doesn't really change much. It doesn't help that much. And if we take it out, we can save a whole bunch of space and power. So we're going to do that. Whether that was for thermal management, like you say, or not, who am I to say? But they have removed it for Ultra and beyond. Whereas AMD hasn't. AMD still has hyperthreading or simultaneous multi-threading, or SMT as they call it. So it's just a different way of doing the same things. Pretty much, yeah. You can do stuff hybridly, having, powerful but power hungry cores and low power, low performance cores, or and sort of have essentially the two ends of the spectrum, or you can do what AMD is trying to do and sit in the middle with just as performant cores but almost as power efficient as well. To the outside observer, you could potentially make the argument, although I don't know how much I believe this argument, but I'm hypothesizing arguments here, that Intel chose to make hybrid chips because they were unable to improve the efficiency of their primary cores. Again, whether or not I believe that, I'm not entirely sure, but yeah. I see a lot of CAD and content creators using Intel CPUs, whereas I see more strictly gamers using more AMD CPUs. So that, especially these days, is what we call mind share. Mind share is basically marketing, or the historical marketing. So, where back in ye olde days, like, I don't know, anywhere from 2012 to 2017, 2018, AMD CPUs were either crap or brand new and therefore unreliable. Prone to crashing, prone to issues, prone to incompatibilities, all that sort of stuff. And so for professionals, CAD, for content creators, for a wide range of professional applications, Intel has a strong history of being reliable, of being the go-to choice, and so it feels like an obvious decision, right? If you rely on your computer to earn you money, or your company relies on you having a reliable computer to earn you money, you're going to pick the thing that isn't necessarily going to be the best performance, but is going to give you the fewest issues, or at least you think. For the longest time, Intel was that choice. Intel was seen as the reliable option, as the stable, steady option to pick. Nowadays, though, AMD has thoroughly taken over the market with some phenomenal chips, and so that is shifting. But the interesting thing to realize is that gamers, as long as the chip works and is the fastest one, that's all that really matters in your purchasing decision. There is some fanboyism, for sure, both ways. But as a cohort, as a big group, gamers are much more likely to change their purchasing decisions sort of on a whim, quicker, based on the available information, whereas businesses, people who rely on the systems, they are much more hesitant to change from what they know, from what they are comfortable with, and what they feel is a secure and reliable choice. That extends to the data center as well. Intel still holds a massive market share in the data center space, because that's what people have been buying for the last 20 years. And it's hard to get people to change their mind about it. One, because they only upgrade every 3 to 5 years. So that delays the process. But also because, all of their expertise is in handling all of these Intel systems. And now, you got to convince them to not only change for, yes, a potentially better, potentially more efficient, potentially more feature-rich option. But you've also got to convince them to relearn, you know, how AMD CPUs work so that they can work out what BIOS settings to change on their servers so that they get the best performance for their virtualization clients. Like, you know, there's some stuff there that you got to learn. And so that slows down the purchasing process. As an example, right? I am a content creator. I'm also a web developer and a programmer. Like, I'm a developer as well. But I have an Intel chip. I have an i9-11-900K. That's the CPU that is in that PC in my desk there. That's not because that's the best chip around. It's clearly not. It's what, 8 core instead of 10 from the last generation. It is not very efficient. It is like 4 generations old. But it's reliable. And admittedly, at the time, I actually swapped off of AMD back to Intel for this. Purely because a rogue 10 gig NIC network card bricked 2 AMD 12 core CPUs, and I'm still angry about that. But yeah, it bricked all of my AMD motherboards, and I needed my system working again. So I was like, okay, well, the only other chips that I have around here are, I think I had, it was 12th or 13th gen was like in the house, but I knew that I needed to use those for further testing. So I grabbed the only like board and chip that I thought I could sort of do without for testing's sake, and I could just buy another one if I really needed one, which was an 11900K. So that's why I have an 11900K, but that's also why I haven't changed off of it. It doesn't really give me many issues. Touch wood. Actually, that's a lie. There are plenty of issues, but they don't cause me enough issues to care. So yeah, I have a 4 or 5 generation old Intel CPU, and it works fine. I don't touch the thing that makes me money, or that I need to use to make me money. I don't break what's not broken. I'm still running a 1000K, and that's fine. Nice. Hello, Essentialist. Also, sorry, Cecil, buying a Snapdragon X Elite now with the discounted price, or waiting for the X Elite 2 laptops. Price range of 800 1,000. Will they come soon? So I couldn't tell you what's coming. I know that the Snapdragon X Elite that I tested, which was the lowest end one, didn't blow me away. So I would be hopeful that a future revision would be really good. But yeah, maybe check out my Acer Aspire X or whatever it's called. A fairly recent Acer video. Check that one out. You'll have my much more cogent thoughts on the Snapdragon chips. I don't get into the brand. I go for what I can afford. Yeah, fair enough. I almost exclusively focus, like when purchasing basically anything, I do my best to focus on the features, the performance, and the price much more than what I might consider the more vanity aspects, like what the brand is and you know, the brand's messaging and that sort of stuff. As to say, I try and be an objective purchaser rather than an emotionally driven purchaser. Makes sense. What you need for the job is something that works acceptably and reliably, whatever it is. Horses for courses, as they say. True. I don't have all the new CPUs and boards sitting around. Yeah, I mean, I have 12th, 13th, and 14th gen chips lying around. I just... Why touch it when it works fine? 1700 XTX been insane. Nice. Do you care much for efficiency? Yes and no. So a lot of the time, actually, including yesterday, all of my systems have been running off of solar because I've just been sort of saving the power up, basically. It's about I think it's about 150 watts, my system, when doing regular stuff. So that's a 4060 Ti, 16 gig, and 1100K, 64 gigs of RAM. Is it 64 or 128? I can't remember. I think it's 64, isn't it? 64, yeah. Couple SSDs, 10 gig NIC, that sort of stuff. AIO. Which isn't great. It'd be nicer if that was lower, but half of that comes from the GPU because that sits at 80 watts quite a lot. Because I have 3 high resolution displays permanently connected and generally doing stuff. And yeah, part of that is obviously the CPU, but I don't think it would be worlds different if I were to go 12th or 13th or whatever. Certainly not 13th. So yeah, I do, but also no. I don't buy for efficiency, but I tune my systems for efficiency and reliability. I mean, yeah, fair enough. And also, hello DT. Happy New Year. My GPU also sits at 90 watts at idle. Yeah. Do I have hardware info open? I do. Give me the pull tabs. There we go. Move over here. Why is it so small? So right now my CPU is drawing 80 watts because it's doing the video encoding, if I remember rightly. The peak that it draws, at least on this boot, which has included editing and rendering, is 170 watts. The GPU is currently drawing 30 watts. The peak that it's drawn... Huh? The peak that it seems to have drawn is 73 watts this sesh. Yeah. Do I have any other power ratings? No. So yeah, probably drawing, I don't know, 150 watts, give or take, right now. There'll be companies, or at least product lines from companies that I'll avoid, but I often won't block an entire company. Yeah. Same. I mean, it depends what, depends what company and brand and that sort of stuff. What they've done to deserve me not buying from them, kind of thing. System is at 28 and 20. Nice. As I said, mine is currently encoding video and sending it on to internet. Why don't more people deshroud their GPUs? It's been amazing for temps and noise. I don't hear my GPU. I'm terrified of cracking the die. So deshroud is taking the fans off, basically, and putting your own fans on, or at least taking the plastic around the fans off, to give more airflow and better, well, temperatures and flow, and therefore less noise. You're thinking of delidding, which is CPUs, where you take the integrated heat spreader off. Oh. My CPU is drawing 108. Nice. Why? I got to see the 6 chiplets next to the main die in the card, which is cool. Nice. Is that? No, that's not RAM. I love life. Thanks, Jim. I hope so too, but the answer is no. This won't go away until after I fall asleep. And then it will be a steady decline back into this tomorrow. What times? It's cache, 16 megabyte per chiplet. Oh, nice. That's cool. Really low density, but I assume very high speed. So. Thanks. I hope I will, but no. My AMD rig idles 80 watts total. I mean, nice. Which AMD chip? Looking forward to the new X3D chips. Yes, but let's face it, the Rampocalypse has really dampened the spirits of the PC building space. Also, if you're interested in the die yield calculator I was talking about earlier, I've stuck it in the chat. It's actually a really cool animation if you hover over the wafer as well, so have a look at that. 9.2 gigabits per second per chiplet. Damn, that's fast. Damn. Yeah, nice. 5950. Oh, nice. I was using a 5900X for a while until my NIC bricked 2 of them. That's what I was asking earlier about if other components get offered to encourage sales. I mean, fair enough, yeah. I wish that was the case. I wish we could ignite some passion. I don't know, we'll see. CES is next week, actually, so by the time we next speak, CES, most of the announcements will have happened. They're all happening on Tuesday, I think. Let me just... Yeah, Tuesday. Tuesday will be a very heavy CES news day, so keep an eye out for that. I'm back to normal videos for now, so there'll be one tomorrow and there'll be one Monday, and then I think I'm aiming to do one on Friday as well. But I need to wait until the CES launches so I can confirm details before then finishing the video, so we'll see. But yeah, I'm going to leave it there. I hope you all have a wonderful week. Happy New Year. Hope you all stay safe. Hope you have fun. Like I said, video tomorrow, Monday, and stream as usual. Back to normal next week. So yeah, thank you very much for watching. Happy New Year. We'll see you all next week. Bye.